Welcome everyone to another Packt live session. And today I'm joined by AI expert and best-selling author Denis Rothman, who has written a new book called
RAG-driven Generative AI. And thank you for the invite, Bavish.
And today, in case you haven't guessed, we'll be talking about Retrieval Augmented Generation. So we'll be giving away 2 e-copies of RAG-driven Generative AI to 2 lucky winners during the session. So comment with #Packt to enter the raffle. And also add your questions to the chat, and we'll try to get through as many of them as we can. Yes, I don't know if someone wants to post if they can hear us okay. But I think while we wait for the comments to come in, do you want to tell us a bit about the new book?
Okay, so I wrote Transformers for Natural Language Processing and Computer Vision, which was published in February. And I touched the topic of RAG, but I had to stop at 700 pages. So something needed to be added. So we needed this new book. To address RAG in detail, because today a generative model has limits. We have to choose between fine-tuning, adding documents, attaching documents to a ChatGPT Copilot or others. So we needed to do that. So now we did it, and it's on the market.
So the first question then. So why and when should I choose Retrieval Augmented Generation over fine-tuning and vice versa?
Okay, so now comes the problems. So let's in this conversation, we will build each response on the previous question, so that by the end of the session, we have built a nice building of RAG for you, the architecture. So first of all, generative AI has limits, as you all know. You can have a model that doesn't know how to answer because it doesn't have the knowledge. It can't know what's going on in your company or a new food product or something. So it can't answer. Or there are things it can't answer because it learns through statistics. So then you're stuck. Or it can't do a lot of calculations so a lot is missing. So then at one point, you're going to say, am I going to fine-tune the model, or am I going to add information? So your first reflex, and I've seen this now, I've talked to a lot of people, is to go to a Copilot, Gemini or ChatGPT, and add a document. So Bavish and I were just talking about that before the beginning of the session. So you attach your document to GPT. Fine. Let's say you're a human resource person. I was talking to a person like that an hour ago, and you attach a couple of resumes and you ask the Copilot to analyze them. Fine. How far are you going to go? How far do you really think you're going to go when it hits a company in the resume and it doesn't know that company? So now you have a nice candidate, but the model doesn't know the company. So you attach the document, but you can see that the document itself can reference to other information that the model doesn't have. So now you're stuck. And many people think they can do that. Oh, I summarized a 50-page document. Oh, you did? What if it referenced other documents? Where are they? Or if you're in the legal department and it references articles of law that aren't in that system and the model doesn't know them. So at one point, you reach the limit of the model, you reach the limit of attaching documents, and you need something more. So either you're going to fine-tune or you're going to add data, but you're going to have to build a data store or a vector store or a file, whatever. You're going to have to build something different. Now you can fine-tune, okay? But what are you going to fine-tune? You're going to have to clean up all the data, and you're going to have to pay, and this is a lot of money. Even if you think it's not a lot of money, you have to pay for the machine resources, human resources to do that, cleaning the data, fine-tuning. Fine. Do that on Monday. Let's say you finished on Tuesday. Wednesday, new information comes in. Okay, you're working in a company on, let's go back to human resources with new resumes. Oh, I didn't fine tune them. Oh, I'll fine tune again. So how much is this going to cost you? So at one point, we're going to go away from hype, uh, learning AI into implementing AI, which is another topic Bavish and I were talking about before the session. How far can you go just imagining AI? So you can't fine tune every day. You can't fine tune every month. You can't fine tune all the time because it's going to cost a fortune. Okay, so now you go and you say, well, let's do something different. Why don't I take the data I have and vectorize it and store it? Now I can take the data and just use raw data, but we're getting to the concept of storing data. So that's the first step, storing data. So now I have two things going on, retrieval and generation. That's not the same thing at all. I'm going to use AI to retrieve data, and I'm going to use AI to generate a response by augmenting the input. So let's go back to some very clear examples. I don't have 2 resumes. Let's say I have 1,000,000 resumes. Okay. Let's say I'm on LinkedIn, and I am LinkedIn, and I have 500 million resumes. Okay. And now I have all that data, and I can use a system to go get a whole list of people like the best engineers in AI or the best data scientists. And from that, I can ask the system to provide a nice list. And then I can send that to the generative AI, which will summarize the profiles and give me some of the best ones. So you can see that the model has a limit. Attaching data to prompts and copilots has a limit. And storing data has no limit. You can store data, as much data as you want. So at one point, there'll be a cost too. So now you go back to fine tuning. And that's up to you to do the calculations. That means that now we're stepping away from learning what AI is to managing AI. So you have to see the cost of storing data, vectorizing it, which means converting it into mathematical format, or you're going to have to fine tune. You're going to have to look at all that cost. So some people might even be tempted to build their own LLM. Well, go ahead. Try to get a model that reaches GPT 4.0 level, and try to get a model that reaches Gemini Flash level. So those are the basic building blocks we're talking about. A retrieval system with data stored that feeds a generative system.
Excellent. Ahmed says hello, and we've got our first question. So, how are RAG updates currently being handled? What are industry best practices to do batch updates for RAG?
So the first answer to your question is how RAG updates being handled currently. So currently, not much is happening, my friends. Okay, we're in a new field. So it's very, so when we're speaking about RAG, it's not like it's been there for 10 years and we have all these best practices. No, you have like 80% of what's going on is just playing around. They're just playing around. Oh yeah, I have this example. I went to Hugging Face to OpenAI. You're just seeing what I call toy experiments. Now in real life implementation, let's take some very serious people like at Google Brain, for example, because OpenAI we speak about all the time. And we speak about Google Brain, and we speak about my favorite person at Google Brain that Babish knows is my favorite, who is Denis Hassabis. Denis Hassabis is a discrete AI genius. So how does he do that currently? Okay. This genius, very discreet, lives in England, not in California, but look him up. He got the Nobel Prize, by the way, in biology. So what you do there is you store the data. Now he's working hard in biology. You got the Nobel Prize for that. So I'm taking a very concrete example. It's not dystopian. It's not imaginative. It's the real thing. He stores the data. And what we do is we store it in vector form. We're going to convert it, okay? We're going to embed it, okay? Which means we're going to convert it into vectors. So they store all that data. I mean, billions of pieces of data. And then the best practice there is they're going to manage the useful information. They're going to delete the bad information, exactly as you do for databases. It's exactly the same practice. It's just a bit different because you're supposed to embed it. So you have a vector plus the literal data. So you have the numbers that represent the data, and you'll have the real data. So it's a bit bigger than data, because in a database, you just have the data and some indexes. Here you embed it, and you apply exactly the same thing as you do for databases. You have to delete the information that's useless, keep the best one. And then what they do is they're going to retrieve data that's interesting with AI. You can even use generative AI to filter that and pump what's interesting out of it, and then feed it back into a generative AI system that can produce sequences like DNA sequences. Now, the batch updates is something I speak about in chapter 6 of the book. We have to address that problem. It's exactly the same thing as for databases. Let's say I have an Oracle database. I'm an Oracle database administrator. Well, I'm going to do batch updating when it's necessary. So all these best practices, go look at what Oracle does, for example, or SQL Server for enterprise. These are standard database practices. And don't get fooled by people that say, yeah, but AI is different. No, AI is not different. The only thing is that you have to embed them. So you're just doubling the size of the system. But these are the same practices.
So next question, Sumanta. So I think, again, this was an interesting one. How good is RAG at handling tabular data for calculations in SQL query generation?
Yeah, that's a good question, because it can't be that good. If you're taking, so let's Sumanta, let's do it in two parts. Let's be optimistic and let's be pessimistic. Okay. So first I'll be optimistic. Okay. So in chapter 6 of the book, I have tabular data. Oh, we're so happy with tabular data. And it's a bank. So I have all the names of all these people, their bank account, how much they have on their bank account, how they use their credit card score. That's tabular data, okay, that I picked off from Kaggle, okay? In fact, I was with the CEO of Kaggle in the United Nations General Assembly session with him, talking about all these topics. So you have all that tabular data. That's fine. You can use SQL. That's right. You can use SQL to get information out of the bank. I'm still in the optimistic part, okay? We'll get to the pessimistic. So I'm trying to do SQL. And in fact, now I'm trying to do a marketing campaign for certain profiles, in this huge data set, okay? So let's say you have 1 million records. So I write an SQL, find the best customers, and then you do some a little approximations and all that, but you won't get a very precise answer, because SQL, there's a framework. You can't go that far with SQL if you're beginning to add difficult criteria. Now, what I did in that chapter is I said, just here are some profiles I'm looking at. Go find the best profiles in the data set with generative AI. Now I can use embedding. I can use vectors. So I can go beyond SQL and get things that you can't get with SQL, because generative AI is so flexible. So with these vectors, I can get the nearest ones. Whereas with SQL, if it doesn't fit in my approximations, like superior to inferior, it won't work. So that's fantastic. So that means that I've targeted a market. I have a whole list of people, and now I can in fact, in this chapter, I sent automatic emails, advertising, considering your profile, you might to buy this, you might. So that's fantastic with tabular data, okay? So now you're saying, well, Dennis, that's exciting. And I say, no, 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 no. There's a limit, my friend. There's a big limit because you added calculation to your questions. You added calculations, and calculations is something a generative AI can't do. That's a very important topic you brought up there. Generative AI is about taking a sequence and continuing. If you ask it to play chess, it can't play chess. No, 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 no. It can find old chess games and comment, but it can't calculate something new. And if you want the decimals of pi, for example, 314, 82, and you want to continue, it knows some things by heart, but it won't calculate new ones. So now with your tabular data, you have a problem. You're not going to send a SpaceX rocket into space or get the booster back on Earth with generative AI. You need physical calculations. And if you're talking about financial tabular data, you're going to need financial calculations. So what is the latest generative AI do? It takes all that tabular data and it tries to write a little Python program or something, do the calculations. But that's not generative AI. It means we're adding functions to it. So the limit is it doesn't know how to calculate, but now it's learning we're learning how to add functions to the pipelines. So I would say if we're talking pure RAG, you can do a lot of things, but you will have to add calculations to your pipeline. You'll have to have a more complex system than just generative AI, meaning that I might have to extract tabular data with using AI, but then I might have to use machine learning or classical software for calculations and then give it back to generative AI. So you see where the market is going? We're going into complexity.
So the next question is probably the one I should have started the session with, but what is RAG-driven Generative AI and how does it enhance the performance of large language models in generating responses?
Yeah, okay, so let's take a simple topic, okay? You take, let's take a Copilot, whether it's Gemini, Llama, or GPT-4o, okay? Let's take an author in literature, okay, an author that's not that famous. I have a name of a French author that no one knows here, Gilbert Cesbron, Gilbert Cesbron. Say, who the heck is he? Well, there are a lot of people studying him because he wrote a huge number of books and was very, very famous at a time, but he just got out of fashion. So on internet, on the web, you don't find that much. So these models, they didn't find it. They didn't find much about him. You'll find things, but they're mostly wrong, or he might make mistakes, which we call hallucinations. But hallucinations are just another way of saying that making mistakes, okay? When you go to school and a student makes a mistake, you don't say you're hallucinating. No, you made a mistake. You just wrote nonsense on your dissertation. You just wrote nonsense. We don't say you're hallucinating. So hallucinating is a nice word to say nonsense. So no, it doesn't know anything about this author. So what can you do? How can you use your generative AI? But you can't. So you can try to attach all his books to the Copilot. Sure, try that. But there's a context limit. You'll reach the context limit. It says, no, you can't add that context. Oh, I'm going to take the API. Go to the API and add the context. You'll have a context window also. Even it's a big one. So if you can add 10 books, I mean, it's ridiculous because they can't analyze these 10 books. So now this is where RAG comes in. You feed the 10 PDFs to like Pinecone or Deep Lake, okay? What are they going to do? They'll take every paragraph of the books, of all those books, every paragraph, and embed them, means converting them into vectors, mathematical vectors, every paragraph, and even every sentence if you want. These are called chunks, every one of them if you want. And it will store them in a vector store, like Deep Lake or Pinecone or Chroma. And now we're not at generative AI yet. We just have this huge data set, which is embedded sentence by sentence, page by page. So now when I ask a question about this author, it knows everything, all the way down to a sentence. So I'll first retrieve the information. Okay, I'll retrieve it with a generative AI system, which Deep Lake and Pinecone can do with Llama Index, for example, which is fantastic. Okay, so now I've extracted extremely precise data. It's not just attaching PDFs to a Copilot. From there, now I can feed some very interesting data from my query, like sum up this book. It'll go get all the important information, all that book, and give it to a generative AI model and say, now continue my context, summarize the book, and you'll get a fantastic answer. That's the future of AI in any case. So you can see that I'm going from a place where the model is nice, GPT-4o, Gemini, they're nice, but they don't know much. From another spot where I'm going to have some things separate with a huge amount of information, and I'm going to retrieve it, and I'm going to feed it some very, very precise things. And as AI becomes professional, you'll need that. You'll need that if you're implementing this in a legal environment, a legal company. Okay, you'll need that if you're going into a medical company. You'll need that if you go into marketing. You can't just go in there and say, oh yeah, here's an LLM and let's have fun. You're not going to have fun for long because you're going to have legal problems. You're going to be sued because you're not giving good answers. So basically, it's giving extremely precise information to a model that doesn't know anything about the topic or not enough.
And got another question here. So how do RAG systems filter and prioritize relevant data during retrieval to ensure accurate and contextually appropriate responses? And
Okay.
what safeguards can be implemented to prevent the inclusion of irrelevant?
There's a lot in that question. So
Yeah,
the first thing is we don't know how to do that. I mean, a human being cannot filter and prioritize relevant data looking at, let's say, 1,000 books in a library, for example. So we rely on Pinecone, Deep Lake, and Llama Index to do that. Now, how do they do that? They take your input, they take your input. So let's say they convert your input into a mathematical string. Okay, let's convert this into Google Maps. Okay, let's say Google Maps is the whole map of all the knowledge you stored in your data set. Let's say the GPS coordinates are the vector. Let's just start with XY. You know that with a GPS coordinate XY, you can find any city in the world. Okay, so now my data has these two coordinates. In fact, the data in reality has maybe 1,536 coordinates, which makes extremely powerful. Let's stop at 2, okay? So now my input says, let's take, I don't know, a city, let's take a city in India. Let's say Mumbai, okay? So my input is Mumbai in the world. Now, where is the best place where I can sell services? Maybe the United States. So now it's going to go and calculate distances. Or let's say if I'm in New York City, what is the closest place to, what is the closest place to go to a beach? Long Island, New Jersey, or Florida? Okay, so I can easily see that from New York, the closest place will be New Jersey or Long Island, not Florida. That's the same for data. It's going to go look in this data. It's going to convert your input into these coordinates. Let's say GPS coordinates multiplied by thousands of dimensions, but take it there. And it's going to look in that data set to find the closest thing to those coordinates and say, New Jersey. Okay, that's that book by Mark Twain that I'm looking for. So it's a question of calculating distances. Just put that in your mind, distances. What is the distance between my input and the closest data that has been vectorized in mathematical format, let's say GPS format, to get there? So when you drive your car, you don't want to go too far. You want the closest place. You want the best route to get there. And it will find, so these systems like Llama Index are extremely powerful. I mean, they are extremely powerful. They include generative AI models in them. You have Llama Index today that includes automatic chunking, embedding, and retrieval. You don't have to do anything. In one of those chapters, I just wrote it, write 3 lines and it does it. So basically, it will find the best data. Now, you don't need to trust that answer because remember, there's retrieval and generation. So when it comes out, you can have a filter. You can have a moderator. You can even use a generative AI moderator that will look for words you don't want. So you can have a full list of words before you add that answer it's going to give you, that closest data. Before you feed it to the generative AI, you can insert a list of filters. I don't want it to say that. I don't want it to say this. I don't agree with this. I don't agree with that. And you just stop it. And in chapter 5, I explain how this goes to a human feedback. It goes to a person in the company. It says, this was rejected. Why was it rejected? Let me see what's going on. So you can let the system give it to you, and you can still filter. Now, the priority will be given by the system because it'll do it better than us. But if we don't like it, go to chapter 5 in the book, and you can change all this. You can say, I don't want that anymore. When in that data set, I'm pulling that data out, and I want an expert to feed something better in there. Okay, so now it's pretty accurate, and it's contextually appropriate. Now, contextually appropriate doesn't mean we're over, because on September 12th, when I spoke at the United Nations General Assembly, and the question was, what is the impact on local culture and language? Because now we have a problem that you're going to have to address. We retrieved the best data to the input. That's great. We filtered it, but the model is American. Llama, Gemini, these are American models. But not everyone lives in the United States. If you live in Saudi Arabia, you don't have the same cultural views. If you live in India, you don't. If you live in Russia, you don't. If you live in South Africa, you don't. If you live in Cameroon, you don't. And we are scientists. We're not here to judge countries. We're here to provide something accurate from the cultural perception of the people that are going to use it. We're not there to judge them. That we're not some world court where it says, here's what's right and wrong. So now you have a problem, a cultural problem that you're going to have to deal with. And that was the topic on September 12th. And I was with several people in there. We were trying to figure it out. So you might have to have a cultural filter. And if you have a cultural filter, then you can go back and feed your data set with your cultural data. Okay, suppose it's just like how to respect holidays. I'm not going to go into politics, religion, and anything. It's not my business. I'm a scientist. It's none of my business. My business is to provide something good for the user. So you might have things on holidays. This holiday is important for us. You can add information to your RAG system that the model doesn't like. That model will not give it to you because it's blocked in cultural views. And you can say, I'm going to change that with my RAG data set and give a big importance to that data. And now you have a culturally adapted system for your users. So then safeguards, we did it to prevent the hallucinant and harmful. Yeah, I think I've covered that question.
Excellent. So I think we can do our first raffle, and just bear with me. So I'll do the first draw, and let's see who comes up as a winner. It says Aaron Bagel. Bagale. Yeah, can you then drop me a message on LinkedIn and with your email address, and I'll send you an ebook straight away.
Babish, there's a question up there by Werner Toplak. I have many PDF files and I want to vectorize them. What steps are there? Yeah, that one. Because that's something very practical. Werner's sitting there and says, you guys are nice guys. What do I do if I have 1,000 PDF files? I mean, you guys are pretty funny. I like your explanation, but what are you going to do? Suppose I have 1,000 PDF files. Okay, so this you'll see as soon as chapter 2, I think, Werner, is you can give me 1 million PDF files. Okay, what it will do is you first have a program. It's an automatic program that will clean the files. It will read every single PDF file, and you can do it. You don't have to load them all at the same time. You can load, maybe you can have a system that will process 100 at a time or 1,000 at a time if you have computer software constraints. But in any case, you can batch it, okay? So now let's say I take a batch of PDF files. The first thing it will do, Werner, is clean the files. It's going to take out all these things as subscribe and things that have nothing to do with the text. Now you have like Beautiful Soup that does that. I explained that in chapter 2. Beautiful Soup does that very well. That's why it's called Beautiful Soup, because that's what we get. We get soup in these PDF files and we make beautiful things out of them. Once they're cleaned, once you clean them up, then we can send them. We just send what we have, that raw data. You can upload it. You can upload the data to a vector store. Deep Lake, Pinecone, they'll do all with Llama Index. It's done automatically. You don't have to write anything. You just have to give the location. Then you look at the chapter. The GitHub repository is free, by the way. So you just look at the program. You can say, oh, all I have to do is give the location, and it will send it. Now you can manually chunk the data, like I was explaining earlier, cut it into sentences, or you can look in one of the chapters where Llama Index does it by itself. So basically, either you choose the size of each chunk, like a paragraph or a sentence. Once it has it, it will convert it into a vector and store it on your vector store. This is automatic. You don't write programs for that. You can just give a parameter. So basically takes the PDF files, cleans them up, chunks them either automatically or you choose a parameter, vectorizes them, transforms them in these GPS coordinates, but with many, sometimes thousands of them, and stores them in the vector store with its coordinates for distances and the literal text you have or image or sound or anything you want in there. So once so the tokenization is done automatically by the system. Now you don't need to tokenize your text, okay? You can vectorize a sentence or you can vectorize the words. You don't need to worry about that. That's done automatically by these vector stores and their tools. That's what's very new about all this. We don't have to do all that work. And now the mapping, as you can see, which is a nice word I like, is done automatically too, because since it's converted into these vectors, these GPS coordinates, very complex ones, it's done automatically. Okay, so now the tools I recommend. Now, there's one thing everyone knows: I don't recommend anything, okay, because I'm agnostic. I don't believe that any tool is the ultimate tool. You have Hugging Face, you have OpenAI, you have Google. Let's say that in the book, I chose the Ferraris, okay? I admit, mea culpa, I admit I chose the Ferraris and the Porsche and the Mercedes for the book. So I go to OpenAI a lot because OpenAI right now is just pouring billions in there, and it has some very nice things that these platforms use, by the way, also. Even when it's behind the scenes, I can recognize the OpenAI models. So all you have to do is just follow the platforms and the tools, and you'll do this. You can get, like, let's say you can get to work in a few hours once you understand how it works, and then you do it batch by batch, because the vector store, you can fill it up little by little. You don't have to do everything the same day. You can add something the day after, then you can delete things, just like a normal database, but it will have two big parts, the GPS coordinates vectors with maybe 1,536 GPS coordinates per sentence, and then you have the real sentence. So it's pretty much seamless, Werner. Now it's becoming a new world.
Sabo has a question. Just how do you define a co-pilot?
Yes, now that's a fantastic question because who's the co-pilot of who in there? Because right now, so let's say, first of all, when we're talking about a co-pilot, we're talking about an AI agent, okay? It's an algorithm. Now, who's the co-pilot of who in there? Because right now, what I'm seeing is things I don't like, okay? So I'll do it like I did before, what I like and what I don't like, okay? What I like is a co-pilot is an artificial intelligence algorithm with a little interface, okay, like a Gemini or ChatGPT, where you can enter something and it will return something. It's basically software. Input does something, output. That's a co-pilot. Why do we use the co-pilot? Because in between, it's artificial intelligence. It's not just I'm looking for something in an SQL query and it comes out. The co-pilot means that it's doing things extremely powerful and that the output can match my way of doing things. Let's say I have a 10-page document to summarize. So now it's my co-pilot. I'm in a hurry. The boss wants the summary in 1 hour. So I attach the PDF to the co-pilot, and the co-pilot will give me the summary. So it's helping me. It's like a co-pilot in an airplane. You have the pilot that's there looking at something, hopefully, and he's saying to the co-pilot, do this and do that at the same time. The problem is when you go to the dark side is who's the co-pilot? Because now you have systems that are replacing people, and the human is just there. The human is the co-pilot of the AI, which just has to give information to it when it's not doing everything automatically. So before I was working 7 hours a day, now the co-pilot is working instead of me and just asking me for I just need to add something when it needs me. I don't like that, okay? I think it might be useful in some cases, but it isn't. And there's another limit to your co-pilot is that how do I define the prompts? How do I know exactly what to put in there? If I don't know everything, suppose I'm going to a new topic, I don't even know where to start. So the limit of the co-pilot goes back to RAG again, because in the last chapter of the book, I just do everything automatically. I create the prompts are created by the system. Like, for example, let's suppose you have, everyone knows that if you write emails, you're going to get an advertisement if you're not totally closed off from the system, an advertisement on a trip. Suppose you write to a friend, I'd like to visit, I don't know, Hawaii, or like to visit Bombay, or I'd like to visit Hong Kong. Okay, you know that a few days after you might receive an advertisement. Generative AI can do that too. It can have all the email in a company and figure out what you need and do all the work and do all the prompts. So I have one example. For example, a customer sends an email, I would like a marketing campaign on how to do a nice, clean, ecological product and how to sell that. The system can just pick it up, write the prompts itself for generative AI, ask the generative AI for ideas. It's called ideation. Get the ideas, and then just continue. It's just a pipeline. It can generate images, text, and everything. So Copilot is supposed to help us, but not replace us. And if it does replace us, well, then someone needs to get us a job, because otherwise we're not going to be happy people. So there's a good side to it, and there's a side to worry about.
Lauren has a question. How do you choose the best LLM to build your RAG application with?
Okay, so that's something we were talking about, Babish, before the session. So let's say, here's my feeling, right? So remember, I wrote the first monograph on transformers that was published in 2020. That's 2 years before ChatGPT was ever known by the general public. It was published in January. So I'm a veteran here. And what I'll give you my feeling now. I don't have an intellectual response where I'm some kind of guru that's going to tell you something. But my feeling is that we can compare the models, And in fact, we can use the word engine because at one time, OpenAI was using the word engine to compare the models between themselves. So let's take a metaphor. Let's say a model is an engine. Now I would like to compare it to the car industry. Okay? Follow me in this mind experiment. Suppose we're talking about the car industry. Can you manufacture a car? Can you manufacture an engine? How much does that cost? Look at OpenAI. It eats up billions of dollars in months. Google does the same. Meta has billions of dollars, and they have all that data. Microsoft, they have all that data and money. Microsoft has that compute, all these machines that cost fortunes. We don't have that money. Okay, so we can go to Hugging Face, which is free. You can train it to a certain extent, but you won't go that far before they send you to Amazon Web Services to pay. So at one point, it's the question of your need. If it's something extremely simple to do, like a Q&A on a very limited subject, you can go to Hugging Face and you'll find tons of excellent models. If you're looking at something at huge professional level in legal systems, medical, you're going to need to go to Google or OpenAI. You're going to go see where the Ferraris are. Okay, OpenAI is a Ferrari, Microsoft Ferrari, Google Porsche. Then you can always go. Then you can go down and down and down, but you better be sure that you're getting the right model. So it's just like car industries or airplanes. Let's like say, Denis, which airplane should I purchase for my corporate for my company? Oh, well, if you have 5 people, then you just need a small plane. If you have 100 people, you need a bigger plane. If you have 400 people, you need a bigger plane. It will depend on your need. If it's a small need, a very small need, you can go to Hugging Face. If it's a very complex need, you're going to have to build up professionally up all the way up to Google and Google Cloud or Microsoft Azure or IBM or OpenAI. So there's no way around that. So you're going to have to make your own choice based on your cost analysis and your need. There is no silver bullet. There's no magical solution. I'm not going to use OpenAI just to summarize, I don't know, some easy documents that I can do with Hugging Face. Hugging Face has like 20,000 models or even more. So if I need something very simple, I'll go there. If it's very complex, I'll have to go to Google or somewhere else. So you're going to have to find the answer yourself. It's like saying, Denis, which car should I buy? Well, my friend, try them.
So Ashwin has a question. So what are the best practices to create unique responses from a GenAI model? As an example, if I'm processing 100 files in a batch of 10, on the following days, we are trying to create unique response record to store that in a database.
Sure. So, as usual, I'll give you the optimistic answer, and then I'll give you the dirty answer. Let's be dirty. Let's be clean. Let's be dirty. The clean answer is, oh, Ashwin, there's no problem here. Because remember, we're talking about GPS coordinates, distances. So Ashwin, everything's fine. You don't have to worry. RAG is such a super system. Buy the book and you'll solve all the problems in the world. You know, like quack doctors do. You buy my medicine, you'll be cured. So, yeah. So all you have to do is vectorize all that. And you have all these GPS coordinates. And you're saying, Denis, that's so great. And just put your input and it'll go get the best distance. And it'll give you your unique answer because there's a little parameter called K, like Kate. And if you put K equals 1, it will give you a unique answer in that database. And you are Superman. And you can go to your boss and say, I am Superman. And if you put K equal 2, it'll give you 2 best responses. And you know what? You can even re-rank them. You can say, wow, this one's closer than that one. Okay, so that's the big advertisement. They'll say, buy my car, drive fine. That's nice. Now, let me give you the dark side of the moon, like Pink Floyd's. Let me give you to the dark side of this. There is a huge problem with generative AI and RAG. Now, and I go through that in one of the chapters somewhere, maybe chapter 7 on knowledge bases. Let me give you an example that will take the whole system apart and this whole interview apart and explain why human feedback is still necessary and why we humans will be here for a long time. Let me give you a very simple example. Oh, Mr. AI, RAG-driven AI, I would like to write the following input in this huge database we've worked 6 months on. It is extremely precise. It is extremely accurate. It is the best data set in the world. It is vectorized. Yeah. And what are we looking for? I am looking for financial reports. Oh, and what are these reports? Well, they're reports of, I don't know, 1,000 companies. Oh, yeah. And what do these reports contain? Well, they contain everything they did in the year, which, let's say, food processing, so all the product. Oh, well, that's so great. I have this big data set. So now you write, give me the profile, write a profile of what you think is the best company in food processing chocolate, and give me a nice generative presentation, 2 pages. Okay, so look at my input. My input is just 1 sentence. Give me a summary of the best food processing. It's just about that long. How in heck am I going to compare it to the output? The output is going to be that big. How do I know it's right? How do I know it's wrong? How can I measure it? If I use metrics like cosine similarity, it will say, oh, your answer is only 25% good. But that's not right. It's the good answer. What I'm saying is the answer is so big compared to the input that there's no way to know if it's good or not. Let me give you an even stupider example. Write an essay on the usage of AI in the field of schooling. Okay, I wrote 1 sentence. Now it produces a whole essay. How can I measure it with mathematics? It's subjective. If I read the answer, it's like create a movie on a man that goes to the moon. Okay, fine, and you can do that because in the last chapter of my book, I create videos. Who's going to like the movie? How do I know? Every person is going to say something different. I like that movie. I don't like that movie. That movie's not good. That movie's good. You're going to get as many subjective answers, and there's no metric. There's absolutely no metric that can compare a very tiny input to a huge output. So now when you go back to my financial example, how can I know if it's good or not? In fact, I have 1,000 records in there, the pages long. How do I know? It's like at Babish. Give me the summary of the best book of artificial intelligence. So you write that in Packt, you have thousands of books, and it gives you a summary. And you say, how do I know if that's good or not? I'm going to have to go check the books. The only way you could do it, Babish, is go check the books yourself. But how can you know offhand if it was hallucinating, not hallucinating? You don't know. You have to trust it. And why would you trust a machine? So you can't trust it. So you need human feedback all the time until you can trust it. But how long you can trust it? Because you keep producing new books. Every month you put books out. And every month I'll give you a different answer. What's the best book? And it gives you a whole summary. But that summary compared to your input, there's no way to measure it. So what I'm saying is sometimes there's absolutely no way, there's no mathematical objective way to measure the response compared to the input. You want proof? Look at the co-pilots. Look at OpenAI and look at Gemini. You see thumbs up, you see some thumbs down, thumbs up. Why do they do that? because they have absolutely no idea if they gave you a good answer or not. So they're asking you, do you like it? Don't you like it? You like it? Don't you like it? And I showed that in chapter 5. In fact, I even imitated the icons of thumbs up. So at one point they're all lost. All these people are lost. They don't know if they gave you a good answer or not. So they say thumbs up, thumbs down. So that is a very big limit here, Ashwin, that you're going to have to deal with, because there's a limit to artificial intelligence. While everyone's saying artificial intelligence is going to take over the world, I don't know which world it's going to take over, because with all the energy you need and to work the computers, the parameters, and how you know if it's good or not. See how I'm bringing up all these problems? I'm showing you that you can go so far with artificial intelligence and even RAG. And at one time, you're going to have to go tell the people, no, stop. We cannot do this. I need human feedback. I need someone controlling everything. Let me give you a very real example I did. And I was speaking about a few hours ago to someone. In a company, very large apparel company, my AI managed the whole budget. I'm talking about hundreds of millions of euros or dollars. It was euros, but you can think of it in dollars. Hundreds of millions. That means my system was making decisions on hundreds of millions of dollars automatically. No more humans. Automatically, every night, bam, 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 looking at 100 sites in the world and the whole thing. And the person says, is it trustworthy? And I said, I'll tell you what, no, it'll be trustworthy if you control the main responses, and I want something with someone on a keyboard to read the main parts and approve it. I need approval. So at one point, you will need human approval to critical responses.
So might have time for 2 more questions. Let me start with Alexander. So he sort of says, yeah, he understands vectorizing documents. They need to be divided into chunks and nodes. Is there any other reason for converting documents into more detailed units?
Okay, so now, Alexander, you're at the core of RAG. Okay, we've opened the car now, and you're inside, and you're in the really difficult decisions. The first level is, why would I vectorize a document? Okay, I explained that as soon as chapter 1. Why would I vectorize just a Wikipedia article? Why would I do that? Well, I'm not. I'm not going to vectorize everything. So the first answer is, there is no reason to divide a very small document into chunks. Like if you just have one document, if you attach it to the Copilot or you send it to a generative AI with an API, you don't need to chunk anything. That's called naive RAG. Okay, that's naive RAG. Naive RAG means I'm not going to bother with all that. It's too tiny stuff. I'm just going to go pick up these things on PDFs on Wikipedia. Just give me summaries, and I don't want to vector. So that's naive RAG. So the first reason is do not vectorize when it's not necessary. That's a decision you'll have to make. And I show that as soon as chapter 1. Now I get to another problem. I'm getting to a document which is pretty complex. Let's say, I don't know, it's a story. Okay, let's say it's a book. Let's say I want to enter Tolstoy's Peace and War, or I want to enter Mark Twain's, the complete works of Mark Twain. Okay, the complete works of Mark Twain. Okay, now you don't have to chunk. No, I decide I'm not going to chunk. I'm just going to send big books at the same time. So now I'll have this huge vector for a book, but it's imprecise. It's like zooming out of a map. Okay, let's say you're looking, let's go back to Google Maps, and you zoom out. Okay, you can use that. You see the world. Then you zoom back a bit, you see the countries. Now consider each country as a book. Now, if you just use the whole book as a chunk, and you say, I'm looking for a book that speaks about adventures on the Mississippi. Okay, well, it'll give you a book, but it won't give you the details. Okay, it'll just give you the book. But what do you say? I would now like to know about a book on the Mississippi where you can go on a little boat and do something. So now you need something inside the book. Now, you're not going to ask the system to scan the whole book every time, because that's going to consume a lot of energy and it can make mistakes. Okay, so the reason is that's why we chunk it. Okay, so it's like, let's say you have a phone book or you have a list of phone numbers. Okay, you're not going to go through all the phone numbers all the time. So if you vectorize, I have all these names separate, then I can index them. And when I index them, I can go straight to the answer. So now when I chunk them, I index them. So now I have these vectors with indexes, super intelligent indexes, so that when I need something, it will go directly to the chunk. It won't have to go through the whole book. It will go straight to the paragraph and to the sentence where it's mentioned. So it gives you this zoom in thing where you can go straight to the point. Okay, so it's for precision. It gives you precision if you need it. If you don't, so that's for you to zoom. You can zoom back, bigger chunks, and don't zoom. Just use naive. So if you go from naive to chunking with indexes, now you're in advanced. You're in advanced RAG. That's advanced. Okay. And modular is if I decide to do both. I don't need to vectorize everything. I can have a data set with some raw PDFs and one would vectorize them. Now I'm modular. I'm using both techniques. I don't want to vectorize everything.
Sadia has a question. If a RAG model fails to retrieve information, does it generate responses from the model's existing knowledge?
So now you have, as usual, I will give you the optimistic answer and the pessimistic answer. Now you will notice that from the beginning of this conversation, I always go from imagination to realism. Okay, so when I say optimistic, pessimistic, I'm saying it's nice when you talk about it, but when you do it, you have all these problems. Okay, it's like, oh, I'm going to go on vacation from Paris to Nice. Oh, it's so fun. I get in the car. You hit a traffic jam 2 miles from your home and you stay 2 hours in the traffic jam. That's realism. Okay, so I'll give you the imaginative, optimistic, super cool answer, and then I'll give you the realism. So if the RAG model fails to retrieve information from external sources, does it generate responsible from the existing knowledge? Normally, I'm saying normally, the generative models of today are a bit smarter than the ones before. They'll say, I don't know, or I can't answer that question. Bing will do that. If you use the Bing Copilot, sometimes when it can't find things on the internet, it'll say, oh, I can't answer that question. Or if you ask it things about politics, it'll say, ooh, I can't talk about that. Or if you speak about a painting, a Dutch painting with a nude person in the painting, no, I can't talk about that. So when it fails and it's smart, it will say, I don't know. If it's dumb, now we're into realism, it will produce a lot of nonsense. People call that hallucinations. I call that nonsense. So now you're stuck again. You're stuck again because how are you going to know that? So what you have to do is, since we've divided, if you see in the book, we've divided retrieval and generate. We've separated in the pipelines. That means if you get no response from the retrieval, you can detect that. That's something you can detect. And by the way, you can trace all the documents that it does retrieve. So if it doesn't retrieve it, you can just stop there. Bam, I'm not answering. So you don't have to generate. You can have, this is in the code. You have retrieved, and before adding the input in the code, you say, sorry, the system did not retrieve data. It is not reliable enough. Please come back later, or put whatever message you want, but don't ask don't produce an answer. So you don't send it. So you retrieve. If nothing comes out, you do not generate, and you can put it in the code. Sorry, there was no retrieval. The database is not sufficient to answer this question. For quality reasons, we're not answering. And that sends you back to more work and more on your data set. So now, also, does saving a RAG-based train model involve high costs? So it's not a model. You're not training the model. You have a data set which is vectorized, and you have a generative model. The model remains the same. So now where is the cost? You have the API cost of running the model, or the cost of just using a free model, but there's a cost. And the RAG, yes, there is a cost. If you go like to Pinecone, they're going to charge you for every record you load, every record you save, saving, retrieving. They're looking for money. People are not there to help you. These systems are not there because they like you. They're there to make money. So of course there's going to be a cost. If you want to do it yourself, go ahead. You're going to hit Oracle. They're going to charge something and support and maintenance. So you don't have any friends out there. Even if you go to Hugging Face, which looks so nice, they're going to send you to Amazon Web Services and you will pay to store things. So in any case, there's a cost. And what you have to do is take a nice little spreadsheet and look at the cost for each solution and find the best ratio between quality and cost for your example, for your company. And if that cost is too expensive and it doesn't work, well, don't do it. Just go to your management, your customer, and say, hold it a minute. I don't have the privacy I need on this data. We don't know where this data is going through the APIs. I don't know the cost. I don't like the model. So stop. We need to study the subject further. We need to be very careful because we can have legal issues, cost issues, and we don't want to disappoint the users because once they're disappointed, we won't get them again. So you might want to take your time, take a spreadsheet, take all the time you need and say, no, I'm taking another 2 months, but I'm going to study everything from A to Z. And when I have something reliable, we'll start with a little part. We'll just do a little topic. We'll just do one part of the project until it's perfect and the users like it. And once we have the users on board, we can expand. And while you do something small, you can see the return on investment. And you can stop it very early. And if it works, you just build it up. But in any case, do not take any risks.
That's some very good advice there. So I think I'm just conscious of time. So if we do a final raffle draw, and then Dennis, if you're happy to answer any questions after the event in the comment section, then we can do that. So I'll just...
Yeah, so what I do in any case is generally, it might take me a few days, but generally I go back and I read all the comments. And if in the comments I answered them in the video, I'm not going to answer them a second time in the comments because everyone can go back to the video. But if I didn't answer them during this interview, and fortunately enough, I have a good memory, I will answer them in the comment section. And you can also send me messages in the messaging system on LinkedIn or comments in my posts. Sadia, okay. So Sadia, hopefully I answered the question.
So Isel, you're the winner of the second e-copy of the book. Can you just message me on LinkedIn and send me your email address, and I'll send that book to you as soon as possible.
Guzet, PhD.
And I think, yeah, that's it then for this session. I hope everyone's enjoyed it. Hope you enjoyed it too, Dennis.
Sure, we had a nice time here. Good questions.
And yeah, thanks everyone for attending, and see you at the next session.
Okay, bye-bye.